In this video, we will see dry run of the code. Now let's quickly check the dry run of this code. Okay, so we have invert tree function, this node. Okay, what I will do, I will basically call this function, right? So this will be the calling here, invert tree. Okay, and I will call this function with the root node, that is this one. Okay, on this function call. So let's see, if I call this function, I am creating invert tree with I. So suppose I call I4. Okay, this function will call I4. So we will understand by everything. So this is my recursion stack. Okay, recursion stack, and this will be my recursion tree. Okay, so I will call with I4. Now I will come here. I will check, is my root node is null. Okay, that is not null. So I will come here and I will call one more function. Right. So I will call one more function with root dot left. What is root dot left? That is 2. So I will call I2. Right. Here I will call I2. Okay, once I call this function, I will execute this function. Again I will come here and I will check, is my root is null? No, it's not null. Again I will come to this line. See, I am only coming to this line. Again one function called root dot left. So what is the root dot left of 2? That is 1. So I will call I1. Right, I will call I1. Okay, now I will execute I invert tree 1 first of all. Okay, so once I execute, I will directly come here. Again I will check, is my root is null? So root is not null, root is 1. Okay, so again one function called invert tree root dot left. So what is root dot left? That is null. So here I will call I with a null value. Okay, here I will call with I with a null value. Okay, so I will call this null function, right? Now let's execute this null function. Is your root is null? Yes, root is null. So return null. So basically it will return. Okay, so from here I will come to here directly. I will return null. Okay, once this is done, can I say the work of this null function is done, right? Because it is returning, right? So this null function, okay, is done. So basically what I will do, I will simply remove from the stack. Okay, once I have removed it, okay, now where I will come, because I am, see, I am again coming back to the function that is called. So which called me, right? This function invertery null call this. So again I will come to this function and now I will execute this function. Okay. Now what is root dot write? What is root dot write? So basically I called this null. I come back. Okay, and I am next calling again one that is null. Root dot write is also null. So I will call again one more null function. Okay, I will call this with a null value basically. Okay, once I have called it, is root is null? Yes, it is null. So I will come back again here. Okay, and this work is done, right? Work of this function is also done, right? Called Kia and it returned null. So the work is done. So what I will do again, I will come back to here. Okay, I will remove from the stack and now I am here. So now both the calling is done, right? This function is done, this function is done, both the calling is done. Now I will execute these steps. I will swap them. So first of all, what is temp? Temp is root dot left. What is root dot left? Null. What is root dot left will going to be null. So again, even if swapping will happen, it won't change anything, right? So basically this swapping will happen. Temp will store null, null will equals to null, and basically it's swapped. Okay, but both are equal, so nothing will change. So now can I say like this function that called it? Okay, this function that called it, who called it? Two function, right? Basically from two I called root dot left, and the work of root dot left, that is calling these two functions and swapping, is work done, right? So basically this two function that called one, right, this I1, is it complete? Can I say my I1 is complete here? Okay, because they basically called the null values and swapped them. So I1 work is done. It will come to come to I2. Okay, that function is called. So once work is done, it will come to I2, right? So can I say my I1 is also completed? It will simply remove from the stack, right? Now I am at I2. Okay, now I will be again where I will here, basically here, because this function called it, work done is done, left part complete. Then I will come here and I will call root dot write. Okay, what is root dot write? That is 3. So I will call this function, right? Basically I will call to here and I will call with a value of 3. So I will call the value of 3, node of 3. Again, once I have called it, right, 3, again it will call the next function root dot left. Basically root is not equals to null, so it will call again root dot left. What is root dot left? 3 root dot left, that is null, so it will again call null. It will again call null. Alright, so is root is equals to null? Yes, so it will revert back, so it will basically come back. So I will simply remove from this stack. Right, once this is done, again you will come here root dot left and you will call this root dot right. Okay, now you will execute this root dot right. What is root dot right? That is this again null function, null root. So again if you call root dot null, let me put it here as well. If you call this root dot null, root is again equals to null, so it will again come back, so it will again come back, it will again come back. Right, so it will execute from this stack and it will come to I3. Now this is done, this is done. Right, we have called root dot left, this is come back. Right, we have called a root dot right, that is also come back. Now what I will do, I will swap them. So basically what I will swap, I will swap root dot left. What is root dot left? Null. What is root dot right? Null. So swapping won't change anything. So the function I3 is done. Can I say the function is I3 is done? Okay, the function I3 is done. Yes, so it will go to I2. So I3 is done, I will simply remove from the stack. I3 is done, I will simply remove from the stack and I will move to I2. Now once I moved I2, so can I say where my I2 was? Right, I2 called root dot left 1, that is also done. I2 called root dot right, that is 3, that is also done. Now what I will do, I will swap them. Right, so I will swap root dot left. What is root dot left? I1. So basically I will swap I1 and I3. So if I swap these two, right, right, it will become 3 and it will become 1. Right, so basically this is how it will become. Right, 3 and 1. So can I say now the work of I2 is also done? Basically it called I1, it called I3, okay, and it done the swapping. So yes, the work of I2 is also done. It will again move back to I4. Right, I2 is also done. I will simply remove from the recursion stack. Okay, once recursion is done, right, I am at I4. So basically you can see I4 called I2. Right, basically this function root with root 4, I called the root dot left, that was 2. Right, so this is done. Again if I come from the function, I will come to this position and I will call this one invert tree root dot right. So I will call the next function root dot right of 4, that is 7. Right, I will call this function. So I will call this invert of 7. Again once I call this 7, right, again it will execute. Is my root is null? No, 7 root is not null. So again it will call one function root dot left. What is root dot left? This 6. So it will call 6. So let me create it something like this. It will call I7 and 7 it will call again what? I6. So it will call again this function I6. Okay, so I will execute this 6 first. Right, so if I execute this 6 first, okay, I will check is root is equals to null. No, 6 root is not equals to null. Again I will call one function root dot left. What is root dot left? That is null. Okay, so I will call this function null. I will call this function null. So is your root is null? Yes, so it will revert back, so it will simply revert back. Okay, I will simply remove from the execution stack. Okay, once this is done, right, root dot left is done, I will call root dot right. Okay, so root dot right, what is root dot right? Again root dot right is also null, so I will call again one null. Okay, so it will check is root is null. Yes, return null, so it will return. And if it is returning, can I say that work done of this function is also done? Yes, done. Now here we have done the two works. Right, call the left, call the right. Okay, both are done. Okay, then I will swap them. So if I swap them these, right, nothing will happen, right, because if I swap these null, right, both are null, so nothing will happen. Right, so can I say all these work of I6 is done? Right, all the work of I6 is done, so can I say it will also return? So can I simply, I can remove from the stack. Right, it will return. Now from I7, right, I7 called I6. Okay, so basically it called this function. Right, that is done. So I will come to this one invert tree root dot right. So I will call this function 9. invert of 9, right? Once I call this function, I will check is root is null. No, it's 9. It's not null. Okay. Again, one function. Again calling one function. So again, I will call invert of null. So let me put first of all, I will call 9 and then it will call again unto null. I will check is my root is null. Yes. So it will simply return null. Okay. So can I say my work done of this with root null is done? Once this is left is done, it will call right. So it will call right with a null value again, right? I will execute this function. Is the root is null? Yes, return null. So I will return from it. Okay. So I will return from, I called this function. Okay. And I returned from it. So I will remove from it. Okay. Now the work of I9 that was calling root dot left, root dot right, both these thing is done. Okay, now what is the next step? That is swap. So if I swap these null, nothing will change because both are null. So can I say my work done of 9 is also done, right? 9 root is also done. So what I will do, I will simply move back to my previous function call. So I9 will be removed from the execution stack. Okay, so basically, if I when I come back from 9, I will come back where? Right, I will come here because I called these two functions, right? My 7 called I6, basically root dot left. My 7 called I9, that is root dot 9, and the work is done, right? So I called 6, okay, and 9, and the work is done, right? So once I come back, what I will do, I will swap them. So root dot left I will be temp, root dot left will be right, and right will be temp again. So what I will do basically is I7, I will swap them. So I will swap them I6 and I9. So basically I will swap them this 6 and 9 with 9 and 6. Okay. Once this is done, can I say my work done of I7 is done? Right. Basically calling the two functions and swapping. So yes, work done of I7 is done. I will simply remove from the execution stack. I will remove from the execution stack and I will move it. Okay, so now let's talk about I4, right? So I4 function call the two functions, right? Root dot left, that is 2, and root dot right, 7. So once I come back from it, once I return from it, I will be come back here, right? And I will swap them. So I will swap them root dot left. What is root dot left? That is 2. And what is root dot right? That is 7. So I will swap them these two also. So basically what I will do, I will swap these two. So 7 will be come here and 2 will be come here. Once this is done, what I will do, I will simply, can I say my work done of this function is also done? Okay. So basically calling the two functions swapping. So that is also done, right? So I will simply remove from these execution stack. I will remove and now my all the function now recursion stack is empty. Okay. This function is done. And you can see after this, like my tree. Okay. Now it's inverted tree. Okay. So basically this is how it works. Okay. And yeah, basically if you know recursion, if you are good with the function calling, you can easily understand it. Basically is all about how you are calling all these functions. Okay, now let's quickly talk about the time and space complexity. So what will be the time complexity here? So basically here total we have n nodes. Okay, and we are calling each function one time only, right? We are calling each function, right? We have called 7, then 2, then 3, then 1, 9, 6, each one time. So the time complexity will also be big of n. Okay, big of n because you are calling n nodes only, right? And what will be the space complexity? So here space complexity is basically space complexity tells by the only space we have used recursion stack. Okay, remember we are not using any extra variable, but we have this stack, right? And suppose if we are calling thousands of function again and again, so like it will create any space, right? One and one function calling. Okay, so it will create this space. So this is the space that we are taking, right? Recursion stack space, because it will see one function is not completed, still it is not completed, I am calling the next function. That is also basically I called I4. Okay, that is not completed, then I called I2. That is also not completed, then I called I1. Okay, and I am getting this stack memory. Okay, so what is the maximum stack memory that I can achieve? So basically I will say the height of the my tree, right? So the maximum stack will be the longest, you can say the longest branch. Okay, so I can call one function, two function, and three function, and that's it. right? Three function will call null function. That's simply, we can stop here. So the maximum height here, the maximum function calling I am getting, that is 3, right? 3 or 4 if you are taking null, 3 or 4 only, right? So basically our space complexity will be determined by the height of it, not number of nodes, not n. If there are n nodes, I will check the height of it. Okay, what will be the height of the nodes? Okay, that will be your stack memory. So it depends, right? If suppose in this branch, suppose 6 is also having one node, suppose like 8. Okay, so then your height will be like this one, the longest height, the longest branch. Okay, this will be your stack memory, because there will be four functions called 1 2 3 4, right, and so on, right? So basically the space complexity will be the height of your tree, and time complexity will be the number of nodes of the tree. So this will be the time and space complexity of the problem. Okay, we have understood the dry run, we have understood the recursion tree and recursion stack. Yeah, that's all. In the next video we will solve more tree problems. Okay, so check out my next video.